Julian. All right. Okay, so we're back. We spoke about the bubble sort. Now we're going to get into the selection sort. So we have the selection sort. And the selection sort is an alternative sort. I think it's only slightly less terrible than the bubble sort. when you get into the and the selection sort works by marking the current value that you're at and searching the rest of the array. And at the end, when it reaches the end of the array, it swaps the smallest value found with the current value. Okay, so let me go through an example. Again, we could have an array not so big. Okay, so we have an array and we have, let's say we have 91, 2, 17, 8, 15, 37, and 45. And we want to sort this array using a selection sort. What the selection sort is going to do is the selection sort would start off at the beginning and mark that as the current position. And then the selection sort will then look at every other position and mark the smallest position by comparing it to the known smallest. So it starts off assuming that the current position is the smallest position. And then it looks at the next position and it says, is this position smaller than the smallest? And if it is, then it marks this as the smallest position. And it does the same from the smallest position onwards. Is this smaller? No. Is this smaller? No. Is this... Somebody muted me. All right. Is this smaller? No. And is this smaller? No. So at the end of it, it then swaps the current position and the smallest position. So it would swap. So after it does that run through, you get 2 here, 91 here. We know that 2 is smaller. So that this position now, I'm going to draw the whole array. But it marks off 2 from the 91. So we have 17, 8, 15, 37, 45. And this now becomes the current and the smallest. And again, it does the same thing. It looks at this position. Is this smaller? Yes, it is. So it marks this as smaller. Then it looks at this position. Is this smaller? Yes, it is. So it marks this as smaller, as the smallest position. Then it watches this, not smaller, not smaller, not smaller. So at the end, it swaps the current position and the smallest position. So 2, 8, 17, 91, 15, 37, 45. And it continues along like this. Current, smallest. It looks at the position. Is this smaller? No, it's not. Is this smaller? Yes, it is. So it marks this position as smaller. Is this smaller? No. Is this smaller? No. So then it swaps the current and the smallest. So you end up with 2, 8, 15, 91, 17, 37, 45. And we continue like this until the end. I'll run right through it. This was the current and the smallest. Is this smaller? Yes, it is. So we mark this as smaller. Is this smaller? No. Is this smaller? No. So again, 2, 8, 15, 17, 91, 37, and 45. All right. So we end up with a current and smallest being this one. Is this smaller? Yes. Smaller. Is this smaller than 37? No. So 2, 8, 15, 17, 37, 91, and 45. And then it does it for the last one. Current and smallest. Is this smaller? Yes. Smaller. So 2, 8, 15, 17, 37, 45, and 91. And this is our array sorted. Do you understand the concept behind the selection sort? The name selection sort is there because it selects the smallest. It selects the smallest value out of all of the values after the current value, and then it swaps them. Everybody understands the selection sort? You could give me a show of hands, a raise of hand if you, or like a clap, something. Okay.
No worry. I think we understand. I think we understand it.
Thank you. All right. So Valas here dying for human interaction, dying to see somebody face on the on the class video. But they're just they're just quiet, talking into the void. All right. It's fine. It's fine. I
So
know that.
after
Huh?
class, after class for that, sir.
After class for what? For
Um,
interaction.
yes, sir. Yeah, after class.
If I want to interact, I had a WhatsApp earlier. Don't expect no interaction on Teams. All right. Okay. So we're going with the selection sort, and we want to now take a look at the algorithm for the selection sort. And just like the bubble sort, we're going to create a little C file and do the whole thing where we save selection.c. Right? We have the random array created. Oops. I didn't create the random array. So I want this. Right. So let's see. Enter the size of the array we want to use, 10. Okay, so we have an array with 10 random values being generated. And we want to now arrange this using a selection sort. We want to arrange this using a selection sort. So what do we do? How do we go about doing a selection sort? Right? We established that we have our array of values, and we want to move. We have again the same thing where we have an outer array that is responsible for moving along, an outer array that is responsible for being the current value. And that current value only goes up to the second to last value. And the inner array, however, goes from the current value up till the end of the array. Okay? So we have to make a nested for loop. We say for what? For, I believe k was our value for outside is equal to 0. Okay, because k now represents the current value. So this is the current value marker. And we'll use the current value to swap at the end. K is equal to 0. We go up to the second to last value. So we have k is less than what was the variable we used to denote the size of the array? J. J minus 1. That carries us to the second to last value. And then k plus plus. Carries us to the end. It moves us towards the end. And what do we want to do inside of here? Well, we want to say the value s, which is the smallest value, s is equal to k. So mark the position of the smallest value. We mark the position of the smallest value. And why is that? Because this is the value that we're going to swap with at the end. And if we don't find any position that's smaller, then we will end up basically either ignoring the swap or swapping with our current position at the end. Okay? And now we want to move forward and search from the value after the current value towards the end of the array. So we say for, and this is for what? For, it was HIJKL. L is equal to K plus 1. So we're looking from the next value onwards up until the last value, because we have to compare the last value. So we say K is less than J. And then we go, not K is less than J, sorry, L is less than J. And we say L plus plus. And what do we want to do here? We want to say if it is, if the array position that we currently at, if the array position that we currently at when we looking at the moving forward is smaller than the known smallest. Okay, so let me just put a comment here. Say for every position from the one after current to the end of the array, compare that position against the smallest. We want to compare that position against the smallest. So we are now taking a look at array at position K. We checking to see if array at position, not K, sorry, why I keep putting K? L, array at position L. If array at position L is smaller than array at position S. If it's smaller than the known smallest, then we want to make that position S is equal to L. Make that position smallest. Make it smallest. Make it smallest if it is. And once we come to the end of the array, we want to swap the values. We want to swap the values in the smallest with the values where for our current value. So how do we do that? We say temp is equal to array at position K. Okay, so this is to swap the values of current and the smallest. Okay, temp is equal to array at position K. Array at position K is equal to array at position S. And then you see array at position S is equal to temp. And we could wrap this around in an if to just make sure that S and K are not the same thing. Okay, we could wrap it around and make sure that S and K are not the same thing. Let's not do that just yet. Let's run it, printing out all the values. So just like before, we want to print the values in the as it got swapped, right? And we could say, of course, end the pass and put that. And then at the end, we also want to print it out one last time We need to? No, we don't need to in this instance because it will print out one last time here, right? So we'll see all of the passes as it goes. I have a comma there instead of a semicolon. So print the array size that we want to use. Let's keep it small. Let's use 6. Okay, 6, and it did not print out. Why is it not printing out? Did I put it in the wrong position? No, this if is here. Do the swap. Okay, is equal to 0. Let me just print out this outside towards the end and see. All right. I may have put something in the wrong place. Do not panic, students. We will work this out. It's all part of the problem solving process. Okay, it's printing out as it is, which means that it's not even going into this loop here for some reason. Let's try and understand why. Right? No need to look so worried, Joshua. Okay, we will we will sort this out. All right. So we have the array printing out. We printed out every position in the array. We have the current value marker. We said that it goes up until Did I copy the wrong thing here? Yes. I think I have to put J minus 1 here, not J minus I. Right? Because this I was from the last position. I think I typed I instead of 1 there. Let me try it and see. Right? Yes. It was that. So I'm going to remove what I put down here because that will be excessive. And let's go with it. So I typed I instead of 1 here. Okay, so that was I just stop giving Joshua trouble. All right. I thought it was funny. You know why? Because I can't see him. He doesn't even have a picture. So, that's the joke. That was there. This is what you have to do when you have nobody else to talk to. Right? And you're all probably going to watch these videos and be like, Sir was real normal in the beginning. But these videos now, all these recordings are like a descent into his madness from just having to talk into the void. If you start from last year looking, he was interacting, a little strange, but whatever. Now he's just talking to anybody. He's just talking to this little light on his computer there, like it's everybody, everybody's there, and he gives them names, right? He calls them, Chanel and David and Ezekiel and Josiah and but you can't blame Sir because sometimes the names don't respond.
Sir, we don't want to interrupt the lesson.
Oh,
may proceed.
conveniently. All right. All of a sudden, it's the most important thing. All right. I will take that as a valid reason, Josiah. All right. So we see here that from the beginning of the array to the end of the array, right? We check every value from the next one, from the one after the current position. And if it is that if any value is found to be smaller than the smaller position, which we marked as the current position at the beginning, then we swap those values. And at the end of checking all of the potential values for the smallest one, we make an actual swap of the smallest one and the current one. Okay? So let's run it and see. Let's have an array of size 6. All right, so we had the original values were 377, 382, 87, 232, 226, and 215. At the end of pass 1, it has identified 87 and it swapped 87 and 377 because that's where the two values were. Okay, then it swapped 215 and 382. and it swapped 226 and 377. Okay, there was nothing to swap, and that's it. That's the end. All right. So this is the selection sort right here, and we could probably improve the selection sort a little bit by saying if S is equal to L, which means that, sorry, if S is unequal to L, which means that if there was no swap done, right? If there was no swap done, then sorry, yeah, if there was a swap, a smaller value found, then we can swap. Otherwise, don't swap. Okay, so let's see if this produces less less actual swaps and steps for the computer to have to do. Okay, so again, let's do an array of size 6. We had pass 1, pass 2, pass 3, pass 4, pass 5, right? Okay, I feel like if this was just one of those instances where we had right up to the end. Okay, let's see again with a number 6. Again, right up to the end. Wow. All right, so it just so happened, I know that the previous one, that there was a little, we'll go 4. All right, let's see if 270. No, but it actually by the end of pass 2 there was nothing to change. So if S isn't equal to L, right? If there was a smaller value found, right, then we will have to change. So, okay, well, we'll have to look into that and see. Okay, but at the very least, it works, right? If we have, let's go with 20, right? We could see that after 19 passes, but I think that for the most part, it had it sorted itself out by this pass right here, because there was still 465 and 440 to go. So I might have to change one more thing or something, so to just get this to not make that last pass or whatever. But it's something that you could look into. Do we understand the selection sort?
Yeah, but so.
A bit.
Mm-hmm.
What do we not understand about the selection sort?
Like, I don't I understand it, but it's still not integrated in my brain now. You know what I mean? Like, it's not stuck yet.
All right, so you feel like you might need an assignment to get it stuck into your brain.
I was not implying that.
I mean, it's, the best way to get it.
That's what he meant.
Thank you so much.
All right, but you all know the reality of it. There is going to be a searching and sorting assignment that will have to come your way, because we have to prove what we know, and we'll be going down to the end of the term with teaching. So this term is really and truly mostly assignment based and coursework stuff. So we've done searching, we've done sorting. In terms of module 1 again to go.
Can we have time to watch over this class first now before you drop that assignment?
No, yeah, it's not gonna come.
I watching this code and I feel
before
like
next week.
it's so foreign. Like, I don't know why.
Nah, it's actually not so bad. It's not so bad.
So anytime
Alright.
code enter the class, I feel like I'm dying. Okay, let's put it real.
Listen, it's not so bad. You all get chance to review the videos on searching and sorting. But just know that there is going to be at some point an assignment coming your way with respect to this, okay? Before the end of the term, which finishes, well, it'll probably have to, be before the 3rd of December, which is in, hey, about 3 weeks, okay? And then we also have to still do the other topics in module 1, which is the abstract data types, the stacks and queues and related activities. And once we could get that done within the next 3 weeks, we have for the most part we'll be finished with the better part of 2 modules. Okay. So we could spend January focusing on refining our SBA because we kinda need to catch up on that as well. But I know that you guys are under pressure. I know that a lot of other teachers are pushing their SBAs, and we are getting to that part of the term with a lot of assignments. So we can take it easy in terms of, because you all, for the most part, you all have I don't want to give you all like a false statement, Hazard might call them out for lying or something. So, but you all have a decent foundation for your SBA going on, for the most part. Okay, so we can spend some time in January focusing on SBAs, and then we could tackle module 3 in the latter half of January, and and work in parallel with the rest of the SBA for that. Okay. Any questions on the selection sort or the bubble sort? Okay, we have to be able to know how to differentiate between these two, right? How to differentiate between the selection sort and the bubble sort. I'm going to just put 2 links to tutorial on the bubble sort and the selection sort in the chat that I think is useful. And these links, however, they use functions for the swap. Hazard?
So yeah, I saw some selection sorts with, I think, entirely new array. Like they put the sorted like after they find the smallest one, they put it in another array, and then after they print out the other array.
That is not really that's not really the selection sort. I feel I know, or maybe that's like an advanced selection sort, maybe a kind of merge sort or something. So, but I will not. I wouldn't. I really and truly would not encourage you all to use a separate array. There's no need to use a separate array for any selection sort. So the way that we do it and the way that CXC does it is this method, where we identify the smaller values and we use the smaller values and then we swap against the current value. Okay? And each time moving forward, you know that what is behind the line has been sorted. So as it moves forward, you know that the values are sorted. And I end up with this last value here of the sorted array. Okay, Hassan?
Yes, sir, no problem.
All right. Okay, so I'm gonna take off the recording at this point.